Today I'm joined by Max, and he's here to talk a little bit about functional programming and its importance as a skill you should learn. Tell me a little bit about yourself, Max, first.
Yeah, so my name's Max. I'm a UQ grad, was part of the UQCS community for, might have been like 3 years. And these days I work at Google Sydney in the photos team. And previous to that, I was an intern at Atlassian and Schedulo. More generally, I did a lot of functional programming at both of those companies, particularly in Scala, for about 3 years. That's me.
Very cool. So I guess first things first, what is functional programming? What makes it different from just regular logic-based programming?
Yeah, so it's a very tricky question, like what is functional programming? The kind of cop-out answer is like it's programming only with functions. And that excludes a lot of constructs that a lot of people would be familiar with in traditionally object-oriented programming. Obviously, that means no objects. It also means things like no variables. It means, those are the kind of two key facts, like, no objects, no variables. And if the most primitive form of functional programming is the lambda calculus. And that's an encoding of a completely Turing complete language just with functions. And you can do like everything you could possibly need with just functions. And modern functional programming is the logical conclusion of that kind of lineage of programming language theory. But what that means in modern day practice, like what does functional programming look like? It often looks like languages where we maintain a couple of properties where we don't like side effects, we don't like things, we don't like modifying variables, we don't like unrestricted IO, we don't like throwing errors.
I don't know if anyone likes throwing errors.
Yeah, no one really likes throwing errors. It's not fun to have them bubble up in the middle of the program yet. It looks like describing everything in data. It looks like having strong type systems to guarantee the validity of your data. It looks like a lot of things. And kind of describing functional programming in those kind of terms is, it's not quite, this is functional programming, but we can kind of look at what it looks like in modern day terms.
Cool. So I guess kind of following along from that, when would you say to kind of use functional programming, or like that kind of approach for solving a problem? Or like what kind of problems have you solved with it in the past?
So some people would like to say like, oh yeah, you can use functional programming for everything. It's functional programming. It can do everything that object-oriented languages can do. I think, if we're talking about our three main paradigms, you have your that kind of compete with each other. You have your object-oriented languages, you have your actor-based languages, and you have your functional languages and functional programming. I think functional programming very much works when you want to build a big pipe that takes inputs and spits outputs. The thing that you would always want to use a functional programming language is a compiler, because a compiler is just a transform from text into code of some description. And that's where a lot of research in terms of functional programming takes place. If you go to Haskell, you're going to have best-in-class tooling for building compilers compared to any other language. Things that you wouldn't want to use functional languages for are things like games. Functional languages, they can deal with state and they can reason with state, but we have things like object-oriented languages and actor-based languages that comes very natural to them. Simulations, you're not going to want to use a functional language. You could, but it's not ideal. But in terms of a lot of modern programming that you might be doing as a grad, functional languages fit pretty well. A lot of backend services are just big pipes from, HTTP requests to a database. A lot of web apps are just big pipes from user inputs to, HTML outputs. And so functional languages really fit the niche of modern web dev in some senses. If you've used React, you're using a manifestation of what's called functional reactive programming. The React devs very much were inspired by some of the patterns that existed in the Haskell community. And so you'll see that when you're doing a lot of programming these days, you're already doing functional programming. And to kind of learn functional programming, you're kind of just continuing with what you're already doing.
Yeah, I think that's a very good way of putting it in like a way that a lot of people don't think about, like especially in terms of web development, where yeah, you are, I guess, just taking inputs from the user and passing them back through one big long pipe, even though there are normally many steps in between.
Yeah, definitely.
How did you actually start getting into functional programming on a slightly different note?
Yeah, it must have been after CSSE 1001 because I kind of came out of 1001 unimpressed with Python. Uh, Python is cool. It's very like, it's simple and it does things very clearly. But I was just kind of left wanting a bit. It just didn't seem fancy enough. I felt like there was like, I think you look at SQL, and SQL's it's a very fancy language. It's very decorative. It does a lot of work and can do some really, really cool things. And I would look at SQL and I'm like, well, that's a really cool language and Python is not this. And so I was kind of like, I went on this journey and like looking for cool languages. And so I first discovered C and I read through K and RC and I was like, oh, okay, it's not C. And then I read about Rust, actually. Rust was the third language I ever learned. And yeah, I was like, this language was really cool. I didn't understand a lot of the concepts because I didn't really have the context for why the language was built like that. I didn't understand why the borrow checker was necessary because I'd never done kind of really like anything multi-threaded that would need to use it. But there were a bunch of constructs in there like traits and, things like option and the kind of like the error types. And there were just like these weird things in Rust that I'd never really seen before. And I quickly like realized they were kind of transposed from Haskell. And so I was like, okay, I started learning Haskell. I'm like, oh, wait, this is it. This is the cool language. And I just spent the next 2 years like learning as much about it as possible. And yeah, they were just kind of the thing I discovered that a lot of the concepts in the Haskell world were kind of, I'm going to say, bold. Like they really wanted to do something, and the community kind of set their mind to like, let's build a language in a community and a standard library and a set of tooling that just lets us do this thing, this crazy thing. We're going to build this lazy, purely functional language that no one had really ever done before, and they just succeeded beyond their wildest dreams. And to just like go through that process of discovering that was like really, really exciting and very fun.
Yeah, I guess on that note, what resources did you find to actually kind of learn it?
Yeah. So I started with Learn Your Haskell, kind of walks you through Haskell in a really like sensible manner. And once I kind of finished that, Stephen Deal's What I Wish I Knew When Learning Haskell, I think that's what it's called. Yeah, is like the Bible of like insane stuff that you can do in the kind of language. And it's not meant to be read from start to finish. It's meant as a reference guide. But I read it from start to finish. And it's like, yeah, really two really fantastic resources. And in some ways, Slack. We had, another one is it's currently the System F. No, it's the Data 61 Haskell course. Let me find the actual official name here. It's the System FP course. So that was out of Data 61/CSIRO by our current university lecturer Tony Morris for Comp 3400. He built this kind of like very interactive course where you're constantly filling in definitions. You get the type signatures and you have to write the implementation. And I learned a lot from that, not so much doing it, but reading it. But I definitely recommend people doing it in person with someone. It's fantastic. So those are kind of like my three main resources: FB course, Learn Your Haskell, and What I Wish I Knew When Learning Haskell.
What was like, I guess, your first kind of project with Haskell or with a functional programming language?
Yeah, I never actually wrote anything big in it, funnily enough.
Okay.
My kind of, I was learning it and then I kind of bailed someone up at a FP meetup and was like, can I have an internship? And they're like, yeah, I suppose. And so the kind of first FP code I was writing was Scala. It was a scheduler, a Brisbane company. And yeah, it was really interesting kind of starting to write FP in an industrial context. Yeah, seeing how it kind of changed and what were interesting parts of that, what I had learned that were like completely irrelevant, and a bunch of stuff that I had no idea about that was really, really quite useful. So yeah, I think, yeah, I never really did any big projects, but I in it, like in my job, yeah, like tons of them. But nothing I can point to open source wise, unfortunately.
I like your how to get an internship 101, learn functional programming, ask for internship.
Yeah,
get an internship.
I always have very bad advice from people like, "Oh, how did you get an internship?" I'm like, "Oh, just ask, bro." Like, yeah, it's very bad advice.
So I guess like back into kind of more how functional programming kind of works. I guess when you have like object orientated, you think of everything is an object and the objects relate to each other.
Yeah.
You have like procedural, you have like each kind of line like runs after the other, and you have like a series of steps that you're kind of writing.
Yeah.
Do you have kind of like a way of thinking, I suppose, for equivalent for functional programming?
Effectively, the kind of core aspect of a functional programming is that the whole program is an expression, right? In a like a Haskell program, the program itself is always bound to a single variable or single name called main, where that main value has a type of IO unit, which says I can do IO operations, and there is no associated value with those IO operations. So you effectively build your entire program as that single value, and that value is made up of many little different IO values all kind of glued together in a fancy way. And then those little values pull out to a bunch of functions that return data constantly. Like the whole program is just one giant big data structure. And so you want to think of like any time you need to do anything like IO, or you need to like something needs to throw an error, or something needs a dependency, you're always returning data and you're always returning things as expressions. And everything is just a giant expression. Everything is a piece of data, and it all gets bound to one single single value at the end of the program. So yeah, I think that's like a great way of like thinking about your program. It's not a set of instructions that the computer in a procedural framework will go through line by line by line. It's just a giant data structure of a description of a program that the compiler looks at and goes, oh, how do I evaluate this description of a program?
Very cool. All right. One last thing, I guess, to kind of wrap up everything you've said. Why do you think someone who's new to computer science, or even someone who's just never really considered functional programming, why do you think that it's worth learning for them?
So like what we've seen in the last, I'm going to say, this is a big question. I can ramble on about it for a very long time. I think in the kind of last 10 years, there's been a kind of functional programming renaissance. We've actually seen a lot of features that were like kind of built and forged in the programming language theory community kind of like escape. There's this great talk by one of the Haskell committee members called Haskell's Escape from the Ivory Tower by Simon Peter Jones. And it was just like, how did this happen? This was built as a research project. We didn't really think anyone would ever end up using it, but it's exploded. And you're seeing that kind of pattern in a lot of languages now. Like we're seeing type classes end up in C++. Swift has like stolen a bunch of really cool features. Rust is this like weird OCaml descendant that everyone's using. React is an expression of FRP. Kotlin is stolen a lot from Scala. Yeah, Julia is a Lisp. So yeah, we're seeing this kind of proliferation of a lot of functional concepts, and the kind of paradigm is like infecting pretty much everything we see. By like learning functional programming, you kind of see the future of this process. You'll be a few years ahead of the curve when this stuff starts to get introduced into languages, when it gets started introduced at the companies you're going to be working at. You're going to be like, I already know this. This is stuff that I've already kind of experienced. And by learning that, you'll be able to kind of drive that process. You'll be able to kind of know the kind of end goals of these kind of processes of functionalifying everything. You'll kind of see the North Star because you've already learned about it. And so I think that's a kind of core thing. A lot of people think there's no kind of future or career by learning. Like you think, oh well, functional programming isn't really used in the real world. And as someone who's had 2 jobs writing it all day, I can definitely say that's like not. It's very much further from the truth. So it's a very fruitful learning exercise. And I think the last thing is like why I started to do it was I actually thought it's easier to program that way. In teams with other skill functional programs, like, we ship things faster. We didn't really have to deal with entire classes of bugs. It was really easy to refactor things. And that is like a core aspect of why I still do it, because I honestly think it is the better way to do programming. And that's why I kind of took it up so much. And it's hard to show that unless you've kind of written it for a while. So I think, that's my biggest urge to a lot of people who might be listening to this is like, just try it. Like the learning curve is, it's definitely really steep. Don't let anyone say that it isn't. But I think like once you're after that curve, you're like, oh wait, this is really cool. Like this is actually working now. I can build some really cool things with it.
Yeah, I think that's a really good answer, honestly. Yeah, thank you for joining me for that talk. I think that's all my questions, unless there is anything else you want to wrap up with.
Not really. I think, just my biggest request is like, do Comp 3400. Great course from what I've seen. Another really fortunate part is particularly the Brisbane community and the greater Australian community is one of the kind of like hives of PLT research and like functional programmers like with jobs. And so if you decide to kind of embark on this journey, I think you'll be definitely very supported by a lot of people in the community, in the UQCS community, in the wider Australian community. And if there's like, feel free to reach out if you have any kind of questions or want help with that. Would love to help anyone who really wants to learn about this stuff. So
Very cool.
Awesome.
Thank you for joining me again, Max, and thank you to everyone for listening. This has been another episode of the Router Podcast.